of this lesson is to model, with or without technological tools, parallel and perpendicular lines, as well as to determine the equation of a line that is parallel or perpendicular to another.
N passes through the point with coordinates -1, 4. The main thing to remember here is that if lines are parallel, as we see here on the right, the slopes are equal to each other. So if we want a line that is parallel to y equals -5x plus 4, the slope of the new line must be -5 and passes through this point. So now we need to find the equation of a line with the slope of -5 that contains the point -1, 4. Now there are two main ways of determining the equation of a line given the slope and a point. We can use just slope-intercept form, which is y equals mx plus b, or we could use point-slope form, which is y minus y1 equals m times the quantity x minus x sub 1. I'm going to go and show this both ways. So if we use slope-intercept form, we can substitute -5 for m, so we'd have y equals -5x plus b, but we still need to determine the y-intercept, and this y-coordinate is not the y-intercept because x is not equal to 0. But this point is on the line, so we can substitute these values into the equation and then solve for b. So we'll substitute -1 for x and +4 for y to determine b. So we'd have 4 equals -5 times -1 plus b. So we have 4 equals 5 plus b. So now we'll subtract 5 on both sides to solve for b. So we have b equals -1. So now we can substitute -1 for b into this equation here, and we have the equation in slope-intercept form. We would have y equals -5x, and then plus -1 is equivalent to minus +1. So this would be our equation in slope-intercept form. Now let's see if we get the same equation if we use point-slope form instead. Remember, in point-slope form, m is still the slope, but x sub 1, y sub 1 are the coordinates of any point on the line. So we'll use -1 for x sub 1 and +4 for y sub 1. So we would have y minus 4 equals -5 times the quantity x, and then here we'd have minus -1, which is equivalent to +1. And now to write this in slope-intercept form, we'll solve for y, so we'll distribute here. So we'd have y minus 4 equals -5x minus 5, and then we add 4 to both sides. This would be 0, and you can see we're going to have the same equation. We'll have y equals -5x, and then this is -1. So as you can see, whichever method you use, the result is the same. It just depends on what method you want to use. Let's go ahead and quickly verify that this line is parallel to the given line and contains the point -1, 4. Right away we can see they have the same slope, so they are parallel. The given equation produced the red line, and the equation that we found produced the blue line. Notice how the blue line does contain the point -1, 4 right here. Has the same slope as the red line, which was -5, and it does have a y-intercept of -1. So this verifies our work is correct. We want to determine the equation of a line that is perpendicular to y equals 2x plus 1 and passes through the point with coordinates -4, 5. If two lines are perpendicular, that means they intersect and form a right angle or a 90-degree angle. And if two lines are perpendicular and their slopes are negative reciprocals of one another, which can be written using this notation here, which can be a little bit confusing. So for example, if this first line had a slope of, let's say, 2/5, then the slope of the second line here would have to be the negative reciprocal, meaning we'll flip this over and then change the sign. So it's going to be negative 5/2. Okay, so back to our problem. We want a line that is perpendicular to y equals 2x plus 1. Well, this line is in slope-intercept form, so we should recognize that the slope of this line is 2 over 1. Therefore, the slope of the perpendicular line would be the negative reciprocal of this. So for the slope of our line, we'll have to flip this over and change the sign. That would give us negative 1/2. Negative 1/2 is the negative reciprocal of 2 over 1. And then we know our line also passes through the point negative 4, 5. Now to determine the equation of the line with the slope of negative 1/2 containing the point negative 4, 5, we can either use slope-intercept form or the point-slope form of the line. And I think for this video we'll show both. So using just slope-intercept form, or the form y equals mx plus b, we would first substitute negative 1/2 for m, so we'd have y equals negative 1/2 x plus b, and then to determine the y-intercept, it's not going to be positive 5 because the x-coordinate is not 0, but since this point is on the line, that means if we substitute these coordinates into the equation, it should satisfy the equation. So we'll substitute negative 4 for x, 5 for y, and then solve for b. So we have 5 equals negative 1/2 times negative 4 plus b, put the negative 4 over 1, so we have 5 equals, notice how this simplifies here, there's 1, 2, and 2, and 2 2's and 4, so this becomes negative 1 times negative 2, don't forget about the sign here. So now if we subtract 2 on both sides, we have b equals, this would be positive 3. So now we have our equation, we'll just substitute positive 3 for b, and the equation will be y equals negative 1/2 x plus 3. And let's go ahead and see if we can get the same equation using point-slope form. Point-slope form of the line is y minus y1 equals m times the quantity x minus x sub 1, where m is the slope, and x sub 1, y sub 1 is a point on the line. So for this situation, x sub 1 is going to be negative 4, and y sub 1 will be positive 5. So we'd have y minus 5 equals negative 1/2 times the quantity x. Now here we have minus negative 4, which is the same as plus 4. And now we'll go ahead and solve this equation for y. So we'll distribute here. So we'll have y minus 5 equals, this would be negative 1/2 x. And then here we have minus 2. And then the last step to solve for y would be to add 5. This would be 0. So we'd have y equals negative 1/2 x. And this would be plus 3. So notice how if we just use slope-intercept form to determine the equation, or if we use point-slope form to determine the equation, the result is the same. And let's go ahead and quickly verify this graphically. We were given the bed line y equals 2x plus 1, and we determined that the equation to the perpendicular line was y equals negative 1/2 x plus 3. Notice how these two lines do intersect in a right angle here. And the blue line does contain the given point that had coordinates negative 4, 5, this point here. So our work looks good. I hope you found this helpful.